So check it out. Today, we algebrists are going to be starting lesson 4.3, and we won't finish it today, certainly, but hopefully through today and tomorrow, we'll be able to knock it out, but we're going to ease into it. Our focus, we're still looking at these rational functions. So we get these big, ugly fractions that we have to factor into all that good stuff with, but we are going to be looking at how does one multiply and divide these things. So multiply and divide. Nice shot. Rational, which I would use the Blackboard Q if I were you, that fancy Q. Rational expressions. Yo, I suppose I can unfreeze that one. Give me like 10 seconds to finish writing this. We are going to multiply and divide rational expressions. That's our focus today. Thank you for the heads up, by the way. Okay, now, when we look at this, the 6th, 7th, 8th grade in there somewhere is how do you multiply and divide fractions? Like, that's really what we're after. So, as our warm-up into this, here is what I want us to do. We are going to first just do a little recall, so it's not even its own section. I want you guys, it's not going to be like a note thing necessarily, but we're going to work through a problem. Here's what I want you to do. I want you to be able to explain it as if you were like tutoring a 6th grader. Okay, we're going to do one quick example and one type of example, and I'm going to give you guys 2 or 3 problems where all I want you to do is to simplify the following expressions for me. Okay, you have to show your work when you're simplifying these. Okay, so to start us off, we're going to go real easy with it. Let's say on A, I want you to completely simplify. Let's say it's 121 44ths. I want you to simplify this. I want you to show the work in simplifying it. You can check on a calculator if you want to math bracket, but I care way more about what goes on from my original answer to the ending answer. You need to be able to explain it to somebody, okay? There's our first one. On B, I want you to do, let's see, we're multiplying and dividing. So we'll do 1/3 times, 1 over x plus 1. I want to see what you guys come up with that. And C, we'll leave blank for a minute because I want to decide which flavor it's going to be depending on how clear your answers are. I'm going to give you guys like 3 minutes. I want you and your neighbors discussing it. Simplify and show all of your work to explain what you're doing. Same thing here. You are simplifying these expressions. Do it to it. I am going to put a C up here just so you guys know because I see some people doing stuff here. I'm going to put a C up here also. Keep working, but I do want you to check once you're done with it. So let's dig into this. Now, depending on how we go about this, there's a lot of different ways that you can think about this, but here's what I'm going to suggest. I think the biggest idea that we pretty consistently have covered in here has been factoring. Like it's I hope clear to you that that has been our focus. Now, this does not feel like a typical factoring problem, but there's a really common mistake that people make when simplifying these that shows up here also that we're going to try to clear up because we're going to see it on this example. Now, with this, if I wanted to factor, and I know it seems weird because these are just numbers, but I'm going to switch to this red color. If I wanted to factor 121, like build a factor tree, whether I physically actually draw it or not, can you guys tell me any numbers that go into 121? Do we all agree, and this is weird with parentheses, but I'm doing it so it stands out. Does everybody agree that this is 11 times what? Okay, it's 11 times 11. That's my numerator. Can I rewrite the denominator with an 11 somehow? What is it? It's 11 times 4. Now, when I write it like this, my rules for fractions is how I can split them up. Right now, we don't have to write this one, but I just want to see if you agree. Even though they're the same, do you agree this is like A times A over A times B? Is that kind of what this looks like right now? Now, can I split up fractions? Meaning, can I write this as A over A times A over B? Does this still work? Why would I want to think like this? What's the benefit of seeing that I have A over A? It's 1. Now, I don't know if you guys had Jarvis, you guys big, what is it called? Big add is maybe what it is. I'm not going to add anything, But without even rewriting it, do you guys agree that I do have 11 divided by 11? And what does that turn into one more time? So we don't normally draw this, and I will never do it again. But do you guys agree that that's really just a 1 hanging out? So when you simplified it, I think if you've done it correctly, everybody got to 11/4. But I really want to draw attention to the fact that if we can get the same factor up top and down below, they divide out to become a 1. That's the whole point that I want to really take away from this. Is that part clear with everybody? Okay. 6th grade stuff feels about the same. Some of you guys said divide by 11, divide by 11. You're okay. But this is how I want us to try to view this. Okay. On this one, we do not cross multiply. And I just want to check here. We might even write this rule next to it or below it. How do you multiply two fractions? A over B times C over D. How does this work? Straight across. AC divided by BD. When do we cross multiply or use the butterfly? When there's equal. And do you know why that's the case? So check it out. We're going to take hot pink, hot think moment real quick. So check it out. If we had 2 over x equals, this is just me thinking, right? We don't have to draw it. You don't want division. Do you agree with that? So how do you undo a divide by 4? We multiply by 4, and we do it to both sides, right? And how do you undo a divide by x? You times by x. Now, is what I did just now, does that really look like cross multiplication? But notice what happens. 4 and 4 divide out, and x divide out. So I wind up just doing 4 times 2 and 1 times x, right? Notice what happens. 4 times 2 we just said, that's like that butterfly situation. And 1 times x, there's the other half of it. We have to do this because it's fraction busting is when the butterfly shows up. Okay, 2 different situations. This is way easier. So if we apply this rule here, I don't think I even need like a line. What do we get with the numerators? 1 over, and I hate that 1, over what? You could say 3 times x plus 3. Is this also correct? I can shove them together to be one fraction. Now, this is super useful, and it's that same property that we had here. We can split these up and move them apart, and that's what we use to help us simplify these ones out. Is part C more like A or more like B? For sure it's like A, and we're going to take a step up. Right now, people try to make a really common mistake. Did anybody look at C and just try to cross these ones out? Okay, it doesn't work. It doesn't work. You have to be able to factor it so that you can get this one situation, something over itself. So natural mistake. This is a really common one. They don't just cross out. So let's factor this just a little bit, and let's see if we can get it to simplify. So the numerator, let's just run through. Is there a GCF here? What? You say mm-hmm or uh-uh? Could you guys tell what it was? It was no? Okay. All right. So there's no GCF. What's the next thing we check? It's a binomial. Is it a difference? That just means subtract. Is it? Do you know the square root of both of them? How does it factor? X plus 1 and x minus 1. How about the denominator? You could group it, or there's another one. The leading coefficient's 1, shortcut, or there's even another one for this. I know the square root of this, and it's exactly half of that if I multiply them. This is a perfect square. Whether you use grouping or perfect square or shortcut, it's going to wind up being this, x plus 1 times x plus 1. Now, something similar I think happened on your quiz this morning, especially on f of x. We have not dealt with it, so if you graphed f of x and that's the one that you ultimately graphed and you went with it, I'm going to give you the points depending on how your graph turns out. But let's apply the same thing that we did on A to this one. Is there a common factor that is 1 when I do the division? This is x plus 1 over x plus 1, right? Now, if you need to take the time, and I don't normally, but is this true? And it's up to you if you want to write this one. Could I split this to be this? X plus 1 over x plus 1 times x minus 1 over x plus 1. I can, right? Now, when we look at this, what's cool about this whole approach is that we're really doing this and this in the same problem. Like it's the same things happening. Why would I bother to write it here like this then? What's very obviously going to happen when we think about it like this? I'm okay with the language for now, but give me a better one. Instead of canceling, they do what? This is 1, and what am I left with? It's just x minus 1 over x plus 1, and we're done with it. Now, this will have implications, and it will have an impact on our graph, but we are going to get there. So as we're looking at this, I'm going to make one little comment here, and we'll just leave this as kind of a hanging question. What does this do on a graph? Now, that is a question that we are going to answer, so we'll get to it. Looking at these, if you can factor, and it's the same thing, it's going to keep happening this year, just so you know. If you can factor, these problems are going to be easy. I want to use the last 2 minutes. We're going to play around on Desmos and just kind of see what happens here. So there's a weird idea kind of floating around in geometry. I guess before we just jump to Desmos, questions about A or B or C? Okay, so cool. No additional homework tonight? What's up? That's like, I'm going to go with how, if you graph the info that you gave me. Don't stress about it.